So our topic is building clinical decision support system for cardiovascular disease based on the knowledge graphs. And here is our background. So the prediction of the cardiovascular disease has great significance for its prevention work. The purpose of our project is to find the related symptoms and indicators for the cardiovascular disease. We will use several algorithms here based on the electronic medical record data to study the risk prediction of the cardiovascular disease. And our model uses techniques such as neural network to characterize and learn the patient's historical EMR data, which can not only effectively capture the time series features of the EMR data, but also consider the potential correlation between them. And our key result here is that the coronary artery related disease has a prominent influence on the prediction of the cardiovascular disease. And here is our workflow during the semester. At milestone 1, we doing the background research about the cardiovascular disease, and we pre-processing the mimic data. At milestone 2, we doing the graph embedding, use the node-to vector methods, and we transfer the EMR data to vectors. At milestone 3, we calculate the distance between patients using the dynamic time wrapping methods, and we find the top 5 similar patients using the k-means clustering. And at milestone 4, we predict the risk of cardiovascular disease and visualize the outcome. And here is our data descriptions. So our data is basic on the MIMIC3 database. Each disease code follows the standards of the 9th edition of the International Classification Disease, which are the ICD-9 code. And the picture showing on the left bottom here is the ICD-9 code and its corresponding disease name and descriptions. And the dataset we are using to further analytics is the admission dataset, which contains the electronic medical record data for over 61,000 patients, and with 19 attributes containing the basic information of the patients, such as their admission number, their admit time to the hospital, and their dispatch time from the hospital, and also their insurance status and their diagnosis from the doctors. So with the understanding of the data, we found there exists over 15 distinct diagnoses, which means that different patients will share the same disease with different but similar symptoms. So the following picture showing the amount of patients that suffered from each disease. So after we filtered the patients who has the cardiovascular disease, our final number of patients is 6,700. So the picture showing here means that each patient has several symptoms associated with the cardiovascular disease. And after we do the data cleaning, we want to encode our EMR data to vectors. And the method here we are using is the node-to-vec. So in our project, since we're using the knowledge graph from the other group as our input, the graph embedding is a more efficient way to analyze the data in this situation. And we can see from the picture on the right, X1 and X2 are nodes. So each node represents the disease, and the edge represents the relationship between each nodes. So since there's no edge between X1 and X2, we can say that X1 disease and X2 disease is not sharing the similarities. The reason we choose node-to-vector here as our graph embedding methods is that the results are weighted in the homomorphy and structural equivalence of the network, and we can adjust the parameter of it. For example, we can adjust the value of P and Q in the right pictures here. And the step we are doing here, and so in this step, what we are doing is to, after we get the knowledge graph from the other group, we embed the EMR data into vectors, and we get a 20-dimensional vector space. And next, when we get the vectors, we want to calculate the distance between the patients. So the method we're using here is the dynamic time wrapping, which can find the points where these two waves are aligned. So the distance between the patients is correct. And in our project, the steps of the dynamic time wrapping are: the first step is to reshape the vectors, and second step is to calculate the distance matrix between the points of two sequences. And the third step is find the path from the lower left corner to the upper right corner that we can see from the right bottom of the pictures. And so that we will get the sum of elements on the path is the smallest. So when we repeat this algorithm to the whole data set, we will finish computing the distance matrix of our data. And the final distance matrix we got here has 6,000 dimensions. And after obtaining the distance matrix, we perform the multiple k-means clustering to evaluate the similarity of our patients. And the results are also displayed in final web page. On the plot below showing the result that when we cluster into two groups, 5 groups, 10 groups, and 30 groups. And this plot showing that the optimal number of clustering is 3. But we can see there are also a peak value at 5 here. So we will continue showing the top 5 similarity in our final result. And after calculate the similarity, we want to do the prediction. The model we are using here is the long short-term memory model. And this model is specifically designs a memory cell to store the historical information, which contains 3 gates. The input gates, forget gates, and output gates. And these 3 gates and design of the independent memory unit makes our model have the ability to preserve, read, reset, and update the long distance historical information. So, and it's also need to mention that since each patient may suffer from multiple disease at the same time, which is a multi-label classification problem. So when we train the model, we use the binary cross entropy for training. And here is the entropy result here. So after that, we got the outcomes. Since our disease dictionary contains 20 major disease, our output is also a vector with the 20-dimensional space here. And the picture on the right bottom shows 4 patients. And we also built a histogram for each patient, which contains the top 5 disease diagnosis code with the highest frequency. And from the histogram, we can see the coronary artery related disease have a permanent influence on the prediction of the cardiovascular disease risk. And here is our data visualization.
Here is our demo. I will share my screen. Here are 5 bottoms. Our system aims at when a patient enters his ID. If his ID is in our database, we could firstly return his records, secondly, the top 5 similar patients, which can be used to do more detailed analysis, such as comparing their test records and others. Thirdly, we could get his top 5 with disease he may get, and he can enter ICD-9 code and serial number cluster 2 to get more information of disease and patients. Here, we use ID and ICD-9 code and set clusters number 2, and here's the result.
So next, we want to discuss about our project. Like first, our dashboard is too simple, so definitely we need to include more information about the patients. And also, since the coronary artery disease is the mainly factor that related to the cardiovascular disease, so in the future work, we need to divide this disease into several subdiseases and to provide a better prediction. And that's it, our project. Thank you for listening.